fellow seminar for Emma Jane Rose. She is a new hire in my program, and she comes from, well, I stole her, whatever, imported her from Trinity College in Dublin. I actually knew her for, I actually didn't know you the whole time you were there, but I had known her from the NIDA intramural program where she worked in the neuroimaging branch for 5 years as a fellow. And so when I lost somebody in my program and I was looking for somebody who could, do neuroimaging, the director at NIDA said, "Get Emma back." So we've got Emma back, and you all have her background and everything in the blurb that was sent out. I don't know how many times. And I apologize for that. I didn't realize how many times it had gone out. And so I'm going to just let her go. And her work is very consistent with what we're doing in the program. So hopefully get an idea of what we're interested in. Okay.
Hey. Oh, I have nowhere to put my water. So good morning and thank you. Good morning. It's afternoon already, right? So thanks for coming. I'm going to talk about most of the work that I did when I was actually a fellow at NIDA. So looking at the neurobiology reward processing in drug-dependent adults, and specifically what we were looking at is these kind of trait versus state effects on reward processes and why they might be important. So I'll tell you what I'm going to tell you. For people who aren't familiar with rewards like pizza and soda and other nice things, I'm going to talk a little bit about what we mean when we talk about rewards. About the reward pathways, these network systems in the brain that mediate reward processes, how dopamine plays a part in reward processing and why it's particularly important in drug addiction or dependence, depending on the terminology you prefer. And then what I'll do is I'll actually specifically outline the two different measures that we did. So I did, and this will hopefully become apparent what I mean by temporal difference error processing. And what we did in terms of looking at it in nicotine and cocaine dependence. And we also looked at incentive salience processing in the same models in humans. And then obviously, given the work that I'm now doing with Denny, I'm going to talk a little bit, hopefully at the end if we have some time, about translational applications of this work, where we want to take this in terms of drug abuse prevention and drug abuse treatment. So what do we mean by rewards? So there are all sorts of things that are primarily rewarding, what we call primary rewards. So things like food, sex, for some of us, chocolate, things that we need for survival. And I'm looking at Denny, in particular when I say the chocolate for survival. And then we have all this host of things that we refer to as secondary rewards. So things that are important to us that we can become dependent upon, like cocktails. Cigarettes, money, music has secondary rewarding processes. You may be particularly enticed by fast cars. And then there's this more kind of modern class of rewards, these so-called social rewards. So things like social inclusion, somebody wanting to friend you on Facebook perhaps, feelings of romantic love, romantic feelings towards other people, even looking at pictures of particularly attractive people. Has been shown to activate the same reward networks in the brain. And what's really interesting about all of these different types of reward processes is that they all seem to be mediated by essentially the same network. They do very similar things in the brain. So essentially what we're talking about is these, excuse me, these mesocortical limbic and nigrostriatal dopamine pathways. So what we have, and I was shown how to do the pointer thing. Can I click on that? There we go. Am I there? No. I might just use the other pointer. Yeah. No, I'm not going to do that. So we have these dopamine neurons projecting from these midbrain areas, so the VTA, ventral tegmental area, and substantia nigra, up into the dorsal and ventral striatum, and then up into the medial prefrontal cortex. All of these regions have been shown in human neuroimaging studies to mediate specific parts of the reward process. So we have these kind of contingency-dependent changes in dopamine firing in these midbrain areas. We have changes in activity in ventral and dorsal striatal areas, usually early on in the reward process. So when we learn associations that predict rewarding stimuli, when something's particularly salient in the environment that predicts a rewarding outcome, when we learn relationships between different stimuli that predict reward or punishment, things that are environmentally relevant to us. And then we have these kind of the more hedonic feelings of pleasure associated with receiving an award being mediated by some of the medial prefrontal regions, so like the orbitofrontal cortex and other areas up there. The medial prefrontal cortex also seems to be important in evaluating reward value So the value of a reinforcing stimulus to a particular individual or organism. Okay. So why is this important to us? So if we take a slightly sidestep, drug addiction is or can be characterized by this particular cycle here. So what we have is once you have initiated drug use and you become dependent upon a drug, you have these states of craving where the individual is particularly driven, has this compulsive desire to seek drug and to consume drug. And this leads into states of binging and intoxication, which when that stops leads into these negative emotional states of withdrawal and anhedonia. And what has been shown again in the human neuroimaging literature is that these processes are at least in part mediated by some of these same components of these reward systems in the brain. Areas like the prefrontal cortex, parts of the striatum seem to be particularly important in some of these phases. They're not the only areas of the brain that mediate this. For example, craving seems to be mediated by function in the insula in particular, but certainly these pathways seem to be particularly important in these key processes in drug addiction. And this is not shown up particularly clearly, but hopefully what this figure is shown, and this was taken from a paper by Neurobilogy, but we have these kind of increases and decreases in these dopaminergic reward pathways that are seen at these various stages in this addiction cycle. So we have involvement of other areas such as the hippocampus and the amygdala feeding into craving states where we see changes in activation in parts of the cingulate, the prefrontal cortex, orbitofrontal region. So again, these parts of the brain that are important in reward value, hedonic experience. When we move into kind of binging and intoxication, loss of control phase of the addiction cycle, we tend to see increases in parts of those systems, so the ventral tegmental area, the nucleus accumbens. We also see top-down control of these processes coming from activations or changes in activation in the frontal cortex. And as we move into withdrawal and back up, we see again we have these changes where we have decreases in certain parts of the reward circuit, such as the anterior cingulate, prefrontal cortex, and again this ramping up of function in parts of the midbrain like the VTA and the nucleus accumbens. And what we end up with is a system that involves a kind of integration of parts of this reward network or reward system in the brain and other kind of ancillary areas like the amygdala and hippocampus, and with these areas all interacting in order to form the experience, I guess, essentially, of drug dependence. Okay, everyone still with me? A lot of brain stuff. So this is what we know about what drugs of abuse do in people who are addicted to those drugs. What's less clear and hasn't been particularly extensively studied is what are these drug-mediated changes doing in reward processing for non-drug rewards. And why this is particularly important is processing for non-drug rewards, other things that are rewarding, whether those be primary rewards, alternative secondary rewards, other social rewards in people's lives. Those factors are particularly important in treatment outcome and how likely people are to stop actually eventually using drugs. And we quite often rely on treatment protocols or treatment paradigms on trying to replace the reward of the drug with the reward of something else. And if we see dysfunction in these reward pathways, is that somehow going to impact upon the efficacy of these treatment approaches? I'll go this way. The other thing that hasn't been well delineated is what are the differences, or is there a differential impact on reward processing between the state of being an addict, so somebody who has had chronic exposure to a drug, and all the changes that that brings upon these reward pathways and other parts of the brain that interact with these reward systems, and the state of acute drug intoxication. So does being an addict do different things to how rewards are processed in the brain versus the state of being an addict who's just taken the drug? Which again is obviously important from a treatment perspective, because if you have people who are continuing to relapse and you're reliant on these reinforcement or rewarding strategies in order to help people stop using drug and it's influenced by taking drug, then you may have a problem. And the other thing that we tried to address was, so there's sometimes a bit of a kind of one-size-fits-all approach to drug abuse treatment, and certainly from the kind of why you might see different pharmacological agents, from a psychological perspective, we tend to rely on the same strategies, whether we're dealing with people who are addicted to drugs like nicotine that would be seen to be less detrimental, perhaps, I mean detrimental to health, but certainly don't seem to have the same impact on people's day-to-day functioning, how they live their lives, versus drugs that can be quite destructive in people's lives, like cocaine. So one of the things, and one of the distinctions between those classes of drugs is that nicotine indirectly stimulates dopaminergic function in these pathways, whereas cocaine, as a stimulant drug, directly stimulates dopamine function in these parts of the brain. And so what we were interested in looking at was, does that difference in how these networks are actually stimulated impact how they're modulated or how they may be changed by drug addiction? Or are essentially all drugs created equal? Like once you pass that first stage of creating change in these networks, is everything else down the line the same? Do we see the same consequences? Can we apply the same theoretical network to treatment? And one thing I want to point out is that the last couple of slides make it sound a little bit like we know what's going on in these parts of the brain, we know what they're doing, and we know how to look at it in drug addiction. What I'd like to point out is that this is just one example, taking a handful of papers looking at striatal function, or that have happened to come across striatal function. And what we find is that specific parts of the brain, so the striatum seems to be involved in the predictability of rewards. It seems to fire when you get monetary rewards. It seems to be involved in the response to social isolation. Is differentially activated by monetary versus social rewards. We see temporal difference error signaling in the ventral striatum. We also see reward anticipation signals. So essentially what we have is an unclear picture of exactly what's going on. And so one of the things that we wanted to do with this study was to try and tap function in these areas, in these networks, and these systems in the brain, but by using probes that would give us the ability to delineate different types of process. Does that make sense? So we wanted to not just select one reward measure and say, well, that's our reward measure that's going to activate these networks. We wanted to actually select a couple of distinct reward paradigms that would allow us to look at different parts of the reward process and see exactly where we were seeing changes related to drug dependence and to acute drug effects. Okay, so what we did was, I'm going to try and explain this as briefly as possible, but we had an experimental paradigm where we took chronically dependent individuals, so we took chronic smokers and we took chronic cocaine addicts, and we looked at them either in a minimally withdrawn state or under the influence of their acute drug of choice. So we had nicotine smokers, cigarette smokers, under the influence of acute nicotine or placebo, and we also had cocaine individuals, either following an acute, like an injection of cocaine, or a saline. And I'll explain those a little bit later, but I'm just going to talk about exactly what the tasks were that we did. And I'm going to talk about the temporal difference. We did two different measures. We did a temporal difference error measure and an incentive salience measure of reward functioning. And the other reason we chose these two particular paradigms is one involves a primary reward and the other one involves a secondary reward. It's also to allow us to look at the distinction between those things across the addicts. Okay, so this was our temporal difference error paradigm. Essentially what we did was we trained individuals in a mock scanner to associate a like cue with the receipt of a small volume of juice 6 seconds later. Easy, right? 70 or some pairings I think they got over the course of 25 minutes or so. We then put them in the scanner, and what we did was, by this point obviously the like cue has become the conditioned stimulus, so they see the like cue 6 seconds later, they expect juice, but in approximately a third of events we didn't give them the juice when they anticipated it, and instead gave them the juice at a kind of pseudo randomly selected interval later. And what the idea is that by not giving the juice when it's expected, you create this negative temporal difference error signal in the brain. So basically there's a kind of, hey, wait a minute, I was supposed to get juice, where is my juice? And then all of a sudden, they're no longer, this is now temporally disconnected from the cue. And so all of a sudden they go, oh, look, I got juice and I did not expect to get juice. And isn't that nice? Or hopefully they thought it was nice, or else the paradigm doesn't work. And so what we anticipate to happen is, so when they're not paired, there's no response to the cue, you get juice, you have an increase in dopamine firing. That's the hypothesis from the animal literature predominantly. So these events here are called catch events. And so the anticipated response in dopamine signaling should be that when we have a normal event, you'll actually see the increase in dopamine firing to the cue that predicts the upcoming reward, but very little, and in fact no real change to the juice itself. And that's a very well replicated finding in the animal literature. What we expect to see, on the other hand, we get catch events is, again, you see this increase to the cue, then a big dip in dopamine firing when you don't get what you expected to get, followed by a sharp increase when you get something pleasant that you weren't expecting. Okay, so what did we do? So we did event-related fMRI. Now, I was just saying to Denny, I'm not going to go into the specifics of the imaging methods because it's not a solely imaging audience, but if anybody is particularly interested, I'm more than happy to talk about it later. For this task, people did approximately 27 minutes of scanning. So there was 3 9-minute blocks. The first block was just a repetition of those training events, so re-establishing the learning signal of I see a like cue, I get juice. And then blocks 2 and 3 included, as I said, about a third catch events. The reason there's only a third catch events is obviously you don't want to dilute your learning signal by giving too many catch events. So if you give loads of catch events and all of a sudden the like cue becomes less predictive. We asked people, this is quite interesting, so this paradigm was based on a paradigm that was run by Sam McClure when he was doing his graduate work. And one of the problems that they'd had was that one of their RAs in the lab had reported that people had started finding the juice aversive by the end of the paradigm. They were no longer finding the juice pleasant. I mean, they're getting really small volumes of juice repeatedly over an almost half-hour period. So what we did was we included a rating at the end of each of the blocks saying how much do you like the juice, so that we could be sure across the course of the experiment that they were still finding the juice at least somewhat rewarding. The good news is that they did find the juice rewarding. And when we came to look at the data analysis, we did all the normal data QC and quality control procedures on the data. And for those who are interested, it was analysed in AFNI. But what we did was we did general linear model analysis where our regressors included the conditioned stimulus, so the like cue, the unconditioned stimulus, so the juice was expected and the juice was received, a negative temporal difference error regressor, which is the juice expected and not received, and then a positive temporal difference error, or PTDE, which was the juice not expected and then received. Okay, and we did both whole brain analyses, so we just let's look at everything. Let's look at everything that's going on in the whole brain while people are performing this task, what changes as a function of these regressors. And we also did an a priori region of interest, or ROI analysis, where essentially what we did was we limited our search area to regions along that reward pathway. So we had medial prefrontal areas, BA10, BA32. We also had substantia nigra, putamen, caudate, and nucleus accumbens, and these are highlighted in different colours here. We did also have a VTA ROI, but that was actually drawn manually because it wasn't in the template that we used for these. There we go. Okay. So for the nicotine study, we had 21 chronically dependent smokers and we had matched controls. The controls were matched for age, gender, race, IQ, years of education. The non-smoking controls had never smoked. We had 2 or 3 that had a couple of cigarettes as teenagers, but that was it. I think that the highest rate of lifetime smoking in the non-smoking controls was something like 5 to 10 cigarettes. These guys were all scanned twice in a kind of counterbalanced design. So the smokers received either a 21 milligram nicotine patch 2 hours before scanning, or they were given a placebo patch. They were blinded as to which patch they were receiving, and they weren't debriefed as to which was which until after the study completion. The scanning started about 2 hours after patch placement. Essentially, the idea here was that by making the scan 2 hours out from the last cigarette, for the placebo condition, what we would have is people who were not acutely withdrawn. So hopefully that within that 2 hour window, they wouldn't have started to go into more advanced stages of nicotine withdrawal, because we weren't specifically interested in looking at withdrawal per se in this study. And then we had an acute nicotine condition. So the 2 hour window was also to allow us to give the nicotine patch time to take effect, essentially. We could have chosen other intervals. It was debated back and forward, but the 2 hours was what we came up with as the best compromise for this. Not withdraw and just acutely influenced by nicotine. The controls had identical scans. The only difference was they had no drug manipulation. Okay. So we did a whole bunch of characterization with these guys. We did full psychiatric histories on them. None of them had any comorbid psychiatric issues. We did personality assessments. We did pre and post session ratings for mood, nicotine withdrawal, and nicotine craving, so that we could be sure that they weren't actually withdrawn in the placebo condition. As I said, we did a bunch of characterization measures. We did a full smoking history on everybody, including the Fagerstrom test for nicotine dependence, which was our primary nicotine dependence measure. And we also asked them how many cigarettes a day, do they smoke, how long have they smoked, how old were they when they first started smoking, what brand of cigarettes did they smoke, a whole slew of information. The other thing that we did with all of these participants, and this is the same actually for the cocaine study, is one of the issues that was brought up was if there's a disruption in this system that allows you to predict the temporal interval between a conditioned stimulus and a reward, if that system's off, can the smokers even appropriately learn, or can they approximate the timing interval associated with the reinforcement learning? So what we did, again, just to address that, was once people were finished the study, outside the scan, and we did a timing paradigm with them where we asked them to judge intervals that approximated the interval between the conditioned stimulus and the reward. So basically, sitting at the bench, they heard 4 intervals, and they were asked whether the last interval was shorter than, longer than, or the same as the preceding intervals. And we also did a blood draw analysis, and the reason we did this is that there's, for those who are familiar with nicotine research, you get differences in nicotine metabolism, somewhat driven by genetic differences, but we were concerned that we may have some people who were fast metabolizers and some people who were slow metabolizers. So at the end of each session, we took blood samples. These were analysed for nicotine and metabolites, and then those values were used as covariates in the analysis. Okay, how are we doing for time? My watch has stopped. Okay, so for the nicotine study, so this is just obviously our mesocortical and nigrostriatal dopamine pathways back up here again, and up here is just the colours for the cues. What's important here is we looked at, so for the midbrain, what we saw was an effect of the event type. So function varied as activity in VTA and in substantia nigra varied as a function of which event type they saw. So we saw increases in activity, in particular for the unconditioned stimulus and the positive temporal difference error event. We saw decreases in activity for the negative temporal difference error event. The one thing we didn't see here was any specific changes associated with the conditioned stimulus. So it looks like really what's going on here is more a mediator of the negative positive aspect, not the predictor, not the reward learning. When we looked at our striatal regions, so we looked at nucleus accumbens, caudate, and putamen, and what we found here was that across all of these regions, there was a main affected group, such that the smokers across conditions had comparatively lower activation across event types in all of the striatal subregions that we tested. So basically less activity in the striatum during this paradigm than we saw in healthy controls. The one thing to note is that we saw no effect of the acute drug manipulation in these individuals for this particular paradigm. There was no effect of acute drug in our whole brain analysis and not in any of the a priori ROI regions that we chose. What we found was just this general, when we compared the smokers across sessions to the controls across their sessions, we see these decreases. To confirm that this wasn't some weird effect of averaging across the 2 different drug conditions, we did replicate the analysis with controls versus smokers in the nicotine conditions, controls versus smokers in the placebo condition, and saw exactly the same pattern. We just lumped it all together to make it easier for summary purposes. And when we looked at the medial prefrontal, we saw a similar effect, i.e. the smokers across conditions showing lower activation across all the event types, and in fact they're barely responding here and here in the nucleus accumbens to those positive events. So very little activity in these guys overall. We also looked at how these differences between the smokers and the controls were influenced by nicotine use characteristics, and again we used basically our whole battery of things that we had. So we looked at acute measures, so time since last cigarette, which was standardised across people, but we looked just in case. We looked at the number of cigarettes they smoked a day, how long they've been smoking for, how old they were when they started to smoke. We also looked at whether or not these changes in function between the smokers and the controlled varied as a function of how dependent the smokers were, so that Fagerstrom nicotine dependence score. And what we found was, so this is in the smokers only, but that in the caudate, nucleus accumbens, and in prefrontal region BA32 in the putamen, we see this decrease, we see this negative correlation, significant negative correlation between smoking duration and function. So essentially, the longer the smoker had smoked, the less activity we saw. Make sense? And we saw a similar, now this looks like it's going in the opposite direction, but what this actually is here is the function in nucleus accumbens plotted against how old they were when they started smoking. So essentially, the younger they were when they started smoking, the less activity they saw. So again, this kind of duration, this chronicity effect in these guys. And similarly here, there was a correlation between the cigarettes per day that they smoked and accumbens activation. Again, there was a bit of an argument we went back and forth with about whether this was an acute measure or a chronic measure. And in my mind, the cigarettes per day is a chronic measure because these are guys who were smoking a pack and upwards a day and had done most of them for 10 or 15 years. I mean, I didn't go into all the demographics, but the smokers were on average in their mid-30s. Most of them had started smoking when they were in their mid-teens. There was one participant who'd started smoking in their 20s, which is what you would expect, right? These guys started smoking early and they continue to smoke. Okay. So what did we find? So with nicotine, we found that there was trait but not state effects of nicotine exposure on reward-related activity for a primary reward. That lower activity in the striatal subregions was there, but and partially in the prefrontal cortex, but not in any of our midbrain regions of interest. As I just showed you, the smoking-related changes, smoking-related reduction in function in these areas correlated with the duration of years of smoking. But interestingly, we found no correlation with how dependent they were. So this really did seem to be something that was predicted by the chronicity, how much they'd actually been exposed to over the long term, rather than just simply how dependent they were on cigarettes. Although it should be noted that these things are not completely independent, right? The longer you smoke for, the more dependent you are. But we certainly didn't find any evidence of functional changes with nicotine dependence. And so the conclusion that we came up with, or what we argued, and this was actually published last year in biological psychiatry, but I guess the argument we make is that nicotine's influence on reward reinforcement, and certainly for primary rewards, might be more related to chronic drug-induced neuroplasticity rather than acute nicotine per se. And indeed, you do see, and there's evidence from the animal literature showing that you have these changes in the upregulation. So you have these upregulated nicotine acetylcholine receptors with chronic nicotine exposure. And those via direct influence either on dopaminergic neurons or via GABAergic neurons do result in a decrease in dopamine firing. You also see a decrease in dopamine firing. Now, I guess chronic nicotine isn't the only thing. You do see a decrease in dopamine firing related to occupancy of these receptors following acute nicotine or smoking. But certainly for this effect that we saw here, the argument that we made that is this may be related to these nicotinic acetylcholine receptor upregulation following chronic nicotine exposure. And one of the key aspects of the results of this particular part of the study, and from a treatment perspective, was that the fact that having acute nicotine on board made no difference to these decreases in function in parts of the brain that mediate reward processing, so which you would expect to be heightened when people have positive feelings, good hedonic experiences. It actually counters this notion that there is out there that nicotine provides a means of coping with negative affect, right? So we've all had this kind of common thing that people are highly stressed, very upset, have a cigarette to feel better. This actually suggests that that might not actually work. That in reality, the having a cigarette and the continued having of cigarettes does very little and actually may exacerbate these types of issues. And this is actually obviously an important factor in the success of nicotine replacement therapy, certainly when you're talking about the idea of replacing all the psychological components of smoking with a pure nicotine replacement. may not actually address a lot of the kind of psychological consequences of stopping smoking and a lot of the kind of negative effects of nicotine withdrawal. Okay. So we did exactly the same paradigm, as I said, in the cocaine users, with slightly smaller groups. This is purely to do with the fact that it's very difficult to get cocaine-dependent adults to stay in for a 4-day study. We also had a lot of participants who were enrolled in the study but then had to be withdrawn because of health concerns. These guys were, on average, in their late 30s, early 40s. Again, most of them had been dependent for extended periods of time. Even if you screen these guys and they're apparently healthy one day, you see a lot of kind of idiosyncratic health issues with these guys. You get a lot of cardiovascular issues. And certainly when you're trying to give people acute cocaine, you want to be absolutely sure that it's safe to do it. So we had, and again, I won't talk about it right now, we did do a whole bunch of pre-training and giving them drug injections and monitoring them for safety and everything before we put them in the scanner. And if anybody wants to talk about it, happy to do so later. But essentially what we did was we put the cocaine guys in, and they had, in one of the sessions, they got acute cocaine approximately 10 minutes before they did the task. Again, enough time to come up and to not be, we wanted them to not be high at that moment. We wanted to pass that initial high phase and just move on to having cocaine on board. They got 30 milligrams per 70 kilograms body weight in a 10 ml bolus over 3 minutes. And then their second scan they did with saline on board. This was also blinded. You'll be really unsurprised to know that they knew when they got cocaine versus getting saline. But we didn't tell them, we didn't confirm it until the end. And again, the controls were scanned twice with no drug manipulation. And again, we did an extensive battery to characterize these guys, and I'm not going to talk about all this today, but we did psychiatric measures, family history measures, personality disorders, a wide range of indices of drug use. We took a whole slew of demographic information from these guys. The controls were matched specifically for these analyses, so we selected a subsample. We had more controls that finished, go figure, than the cocaine-dependent guys. And again, we selected people to be matched for age and gender and race and IQ. And so again, this is quite small. But essentially this, sorry, this was taken from paper. So that's just to illustrate the catch event again. So this was actually an entire 2.5-hour scan session that this particular paradigm was done as part of. The other reward paradigm that if I have time, I'll talk about, but maybe not, was done in the same session. So essentially these guys come in, were set up in the scanner, they got their first injection. About 10 minutes later, we started the first reward task. Did some other stuff, structural scans, resting state, all those kind of things. We gave them their second injection, and then we started this temporal difference error task. And essentially this is just to show the red bars show where they actually got the injections, and this shows levels of cocaine and metabolites across the session. So as you can see, for the cocaine in particular, you get this peak just shortly after, and then it comes down a bit, and then a second peak. And this blue highlighted area is where we actually did the temporal difference error task. So essentially they had cocaine on board, but we were past the primary peak. This slide's just to show the general effect that we got. We did these whole brain and these region of interest analyses with these guys. This is just the main effect of the actual event type. So again, very little response. And I lost my dot. Where have you gone? Can anybody else see that? Oh, no, I'm on the roof. Anyway, so this is just to show that we got an effect of the event type. Again, we see increased function in response to those positive events, so getting the juice when it's expected or getting the juice when it's not expected, decrease in function related to not getting juice when it was expected, very little response for the conditioned stimulus across these guys. What we saw in terms of, and again, quite interestingly, or I'll say, I think it's interesting, we again didn't see an acute drug effect for this particular paradigm. And again, we looked at whether, when we looked at them in the cocaine-dependent individuals in the cocaine condition and the saline condition compared to the controls individually, looked the same. And so again, we averaged across the two sessions. We had no session effects in the controls, so we thought we were justified to do it. And so what we see, I'm pressing the wrong thing. So we see a main affected group in these striatal regions, so bilaterally in the putamen. This is the slide, the part of the slide on the left is from our small volume correction or our ROI analysis. The second half on the right is from the whole brain analysis. But again, we see this bilateral putamen, and we also got a medial prefrontal effect. In all of these regions, activity in the cocaine-dependent individuals was lower than it was in the controls. And we also, and this is probably, I think, the most intriguing part of this particular study, was we saw this group by event type interaction. Again, this slide is in our ROI region. So again, when we looked at across these dopamine reward pathways, and what we found here was we get this effect for these positive events where we see lower activation in the cocaine-dependent individuals versus the controls. And this was true across these clusters that are highlighted here. So we see it for the reward, whether it's predicted or not, essentially. And we see there's the same effect in the same direction across all these regions. We also see a similar effect in our whole brain analysis. In our whole brain analysis, we got, as you can see, huge, big areas of brain that showed differences between the groups, but only for specific event types. And again, we see this relative decrease for the predicted reward and for the unpredicted reward in the cocaine guys. And then really intriguingly, we see a relative increase in activation in the cocaine-dependent guys for the negative events in these regions. So they were essentially less sensitive to what was rewarding in their environment, regardless of whether it was predicted or not, but were more sensitive or showed a greater response to the negative event. Make sense? And again, this wasn't impacted by whether they were under the influence of acute cocaine or not. And again, we went ahead and we looked to see if any of our indices of acute or chronic drug use predicted these changes. And really the most reliable predictor was the time since the last binge that they'd had. Now, this is different from the time that they last used cocaine, because the last time they used cocaine was when they came into the study and we did a drug toleration procedure with them. So this is not a remnant of the recency of drug use. It seems to be that, again, this is in the cocaine users only and in those regions that showed a difference. But for our positive prediction error signal, so here, and here, yeah, we see this correlation between the number of days since they last used, and so the last binge that they had before coming into the study, and activation in these regions. And so the less time it had been, the less active, so the more like the normal healthy controls they were. Does that make sense? Is that clear enough? Yeah. We see the opposite effect for the negative signal. So again, the further out they were from having their last binge, the lower the activity. So again, the further out they were, the more like controls they were. And we see a similar thing. Again, this on the A on the left is the small volume correction analysis, and the B is the whole brain analyses. And again, we see similar effects. This time it was all positive events, or events where you'd expect to see increased functioning. And again, the further they were out from their last binge, the more they start to look like normal healthy controls. So with me? Okay. So what do we see with the cocaine guys? So basically what we found was that the cocaine dependence, not the state of being acutely intoxicated by cocaine, engendered increased responsiveness to negative outcomes and reduced sensitivity to positive outcomes regardless of predictability. One of the things that we can address here, and which I think is really important, and is whether or not this is something that existed in these cocaine dependent guys. Like, were they already less sensitive to things that were rewarding, and does taking drugs do something to those systems to help ameliorate that? Or is this something that's happened to these systems as a result of cocaine? And unlike the nicotine study, we found, as I said, we didn't have any true correlations or associations with any of the chronic measures. So it becomes really difficult to kind of tease those things apart. And we do have genetics on these guys, but for those of you who are familiar with doing imaging genetics analysis, 14 people is way, way short of the number of people that you need to do anything meaningful. One of the things that we're particularly interested in, and one of the things that Denny and I have actually been talking about moving forward, is how these changes and may impact upon high rates of recidivism that we see in cocaine addicts. Most cocaine addicts continue to be cocaine addicts, unfortunately. And what I'm particularly interested in trying to look at is the impact that these changes may have on that kind of compulsive cocaine craving behaviour, cocaine seeking, and how that might be mediated by changes in these dopamine regions. Yeah, and actually, again, similar to the nicotine story, the fact that these differences in function between cocaine-dependent individuals and controls don't seem to be responsive to actually having drug on board may actually factor in escalated use. So if you're taking cocaine in order to have some sort of reinforcing or rewarding experience, or for it to modulate the reinforcing or rewarding experience of other things in your environment, and it doesn't do that, does that then push you to take more cocaine? Does that make sense? So I've taken cocaine and I got a rewarding experience in the early days that I started using cocaine, and now I take it and I don't get these things, and so am I continuing? And am I exacerbating the problem, right? Am I making the likelihood of getting the reinforcing effect lower, but essentially still not getting the effect? Okay. I don't know how much time I have, 15 minutes. I will go through as much of this as I can. I wanted to leave time for questions, obviously. But the second paradigm that we did was a monetary incentive delay task. And the idea here is that you give a cue that predicts an impending reward, a monetary reward. So this time we're looking at a secondary reward. And we actually gave two cues. We gave one cue that predicted the valence of the impending reward. So is it going to be a gain, a loss, or is it going to be neutral, so you won't win or lose anything? We then showed them a second cue, which actually showed them the magnitude of the reward that they could win. So for the loss stimuli, a big cross through it. And then for the gain stimuli, it's just that picture of lots of money. And then for the neutral stimuli, we just did $0. So not very reinforcing. They see a target. So the idea is that they see these stimuli and they're told on the WIN trials that if they respond fast enough to the target, they'll win the amount of money that they see in the second prime condition. If they're not fast enough and they miss it, they'll only win $1. For the loss condition, they're told that if they're fast enough and they respond to the target in time, they'll only lose 75 cents, but if they're too slow, they'll lose the bigger amount of money that they've just been shown, right? So basically, by being fast, you minimize your losses and maximize your gains. And they won real money for this, so they won a percentage of their actual winning, so they could earn up to $50 if they got it all right. And then they get feedback. So basically it tells them what the outcome was on that trial and how much money they have up to date. And we looked at, so it's exactly the same groups, same imaging paradigm, same drug administration paradigm as for the previous task. This time we had 28 nicotine guys and 16 cocaine people. They did 4 blocks of this, so 40 minutes. These were very patient participants who went in the scanner for us for about 2 hours. Again, we did whole brain and SVC analyses. We looked at models, regressors that modeled the valence, so the positive gain outcome, the loss negative outcome, neutral. We looked at the magnitude, so small. We had 3 levels of magnitude, small, medium, large, and we also looked at outcomes, so successful versus unsuccessful. I'll go through this really quickly. The reason that we classified the outcome as successful versus unsuccessful is we had 9 outcomes. Very difficult to have the power to accurately model 9 different outcomes. And what we found when we actually looked at how the brain was responding to the outcomes, and this was actually in healthy controls, but what we found was that when you lose the bigger amount of money, this was in the ventral striatum, this particular cluster, we saw a similar effect in the medial prefrontal cortex. But what you find is that there's very little response when you lose one of the bigger amounts of money. Really similar response when you win $1. So winning $1 had essentially the same brain response as losing a bigger amount of money. However, if you could have lost a big amount of money and you only lost 75 cents, these reward parts of the brain went, oh, that's actually quite good, I only lost 75 cents. And we saw a more similar response to the 75-cent loss as we did to the bigger win amount. So we just classified these things as success or failure. So minimizing your losses and maximizing your gains was success, and then maximizing losses and minimizing gains was failure. Okay, and so what do we see? So here we do start to see some effects specifically of the nicotine patch, and what we found was, I can see this rightly. So Yeah, so in the putamen and in the right anterior cingulate, we see the guys in the nicotine condition show less activation compared to the placebo condition. The guys in the placebo condition show less activation compared to the controls. Similarly, I really need this. I think I need glasses. In the right BA10 and in the left accumbens, we see an effect of the guys in the nicotine condition showing less activation. This is just overall, this is just a group effect compared to the controls. In terms of, so that was for the first stimuli, so for that valence prime. For the magnitude prime, what we find was there was no differences between nicotine versus placebo and no differences between placebo versus control, but the guys in the nicotine condition show an increased level of activity across the different magnitudes for both the prime magnitudes and the loss magnitudes compared to the controls that they're matched with. And this was seen in the caudate. And then we also saw an effect of the outcome. So we saw a differential response for success versus failure in this medial frontal gyrus and the cingulate cluster that was only apparent in the smokers in the nicotine condition. So here it was, you saw it in the smokers in the nicotine condition in the top figure, but not in the placebo condition. And in the lower figure, we saw a similar effect in the cingulate in the smokers in the nicotine condition that was absent in the controls. And again, we looked at whether or not this was predicted by any of our indices in nicotine use. And what we found was that across trial types and conditions, we see a correlation between the plasma nicotine levels that we took and activity in the right putamen. We see it again in the smokers in the nicotine condition for gain anticipation, and in smokers in the placebo condition for loss anticipation, we see a correlation with cigarettes per day. So what we seem to have here is we have some influence of acute nicotine the last time since you actually had nicotine on board. And also here, again, this cigarettes per day, I'm arguing that it's a chronic measure, not necessarily a specifically acute measure. Influence and function in smokers in the kind of minimally withdrawn stage. Okay, 10 minutes. So basically, the argument that we're making here is that these data, so the first study made us think, like, there's not really a lot going on here with acute nicotine for this primary reward. However, when we looked at the data for the second paradigm, what we get is these dissociable effects of chronic and acute nicotine on distinct reward processes. So we're seeing different effects when we look at the valence of an incentive stimulus, the magnitude of that stimulus, and actually the hedonic experience, so the outcome, the pleasurable experience of a reward. We found that acute nicotine enhanced magnitude-related function in the dorsal striatum and outcome-related activity in the medial prefrontal cortex. Both chronic and acute states were associated with altered valence-dependent activity, again in these parts of the brain that we know to be responsive to the value of rewards, the prediction of rewards. And valence-dependent activity in the ventral striatum correlated with plasma nicotine levels across both of our conditions. And in medial prefrontal cortex, as I said, we've got this kind of chronic effect of the number of cigarettes per day, and that seemed to be associated with loss anticipation. So again, this kind of how responsive they were to negative reinforcer or negative stimulus. Got about 4 slides left, I think. So this is the most recent analysis. So there's the least data here. You'll all be glad to hear we're almost there. But what we did was, again, we looked at the same paradigm, and this is just in the cocaine, guys. This doesn't include the controls. But what I found was that when we look at the first prime stimulus, we see an effect of the valence of that stimulus on activity that's impacted by the acute cocaine condition. So basically what we have is that in the acute cocaine condition, the cocaine-dependent guys show a decrease in response to the loss predictive stimuli. No difference for the win predictive stimuli. And then we look at magnitude of effect, we actually get this reversal. And what we find is that for loss magnitude only, there was no difference for the gain magnitude stimuli. But when they see these stimuli that tell them how much they could potentially lose, what we see is that in the acute cocaine condition, there's an increased response in this, excuse me, in this right insula cluster. And then this wasn't actually an effect of the drug condition per se, but what we did find was there was a responsivity to the loss magnitude in the middle frontal gyrus, but again, no responsivity to the gain magnitude. They didn't seem to care at all when we showed them the money, which is quite intriguing for these guys. So what do we have? So in cocaine-dependent individuals, acute cocaine seems to result in functional changes associated with stimuli that predict losses but not gain. So again, the overall picture that we seem to be getting with these guys is that whatever's going on at both the trait level of being a dependent cocaine individual and somewhat the acute state of being under the influence of cocaine seems to be particularly related to negative reinforcement, to punishing stimuli, to things that are adverse in the environment rather than a sensitivity or changes to gain stimuli. We found that acute cocaine reduced valence-dependent activity, but increased function corresponding to loss magnitude. And I guess the question is, does this distinction between valence and magnitude represent some cocaine-mediated distinction in the processing of abstract versus concrete representations of rewards? So you could argue that the response for the loss was there was something to do with seeing money, but they saw money for the gain magnitude stimuli as well. So this distinction between the response, the difference that we see in the valence condition and the magnitude condition may be something to do with the representation of the reward or the punishment in the environment. And again, that may be important for treatment because if we're using abstract representations of rewards rather than real concrete or more concrete representations of rewards or punishments in order to encourage abstinence and maintained abstinence in individuals, then that seems to be an important factor. And as I said here, one of the things, and again, one of the things that we plan to look at is whether or not these changes are important for treatment strategies that in particular rely upon negative reinforcement or the avoidance of negative outcomes. And again, one of the things I guess that I think, or I feel both this and the nicotine study show is that it's important to consider both the trait and the state-related impact on these effects, right? Because it doesn't seem to be consistent, and it's not consistent across measures, and it's not consistent across these two levels. I'm going to just skip this slide because it's just summarising basically what I just told you about the studies. And future directions. So this is the really cool bit, right? So where do we go from here? So essentially what Denny and I have been working on is kind of two arms. So looking at how we can apply these models of the neurobiology of what goes on, not just with reward processing, but with other aspects of cognitive and affective function in drug-dependent adults, how we can apply that to predictive models of prevention and treatment efficacy. Essentially, like how do we take what we know is going on or going wrong in the brains of people who become dependent, who maintain dependence, and how can we use that to either identify people who are at high risk of becoming dependent and how can we intervene and reduce that risk? Or how do we apply that knowledge to better, more good treatment strategies? So is drug abuse liability in high-risk individuals mediated by pre-existing differences in these reward pathways? How does altered reward processing interact with these other risk factors that we know are there for drug abuse and addiction? So, I mean, we all know there's a multitude of things there. We have genetic risks, environmental risks. How does this change in reward processing that may predate drug dependence impact upon those other factors? And can we target motivational processing and prevention strategies? If it's important, what can we do to make it better? And this is really one of those things, like, especially with children and young children, we want to be looking at behavioural strategies, psychological interventions that we can put in place that make a difference to how these things, to these neurobiological substrates of reward and other things. And from the drug abuse treatment, to what extent do these functional alterations in brain systems mediate reward motivation? How do those predict longitudinal outcomes in addicts, or do they predict longitudinal outcomes in addicts? The differential patterns of reward processing predict responsiveness to different treatment strategies. If you're somebody whose reward processing system has been more impacted, are you going to be more responsive, less responsive to different types of treatment? This is also important for those treatments that would be particularly reliant on reinforcement strategy like CBT and those kind of things. And can we use that information to better target treatment strategies, right? Same things don't work for everybody. Again, one size doesn't fit all when it comes to drug abuse treatment. We know that. And can changes in reward processing be used as a biomarker for treatment success? So can we predict long-term changes in drug use from short-term changes in reward processing, either at the level of brain or behaviour? So obviously, we're all at the level, well, me, all at the level of brain, what's going on in the brain, but in reality, it's not, we're not going to scan everybody. We're not going to put every addict or every potential addict in a scanner. And so how can we take what we know or we find out about what's going on in the brain and then actually find behavioural correlates or associations, things that we can actually use out in the field and that will make a difference to how treatment outcomes are for addicts. And that's just all we're going to do like next week. So anyway, so I want to thank Elliot Stein and all the staff at the NRB, all seen here wearing mustaches, for Elliot's birthday. And these studies were all supported by the IRP at NIDA. So I did all of this work when I worked there for Elliot. And also, oh, there should be an RTI logo. It was there, I promise. Well, I want to thank RTI. I want to thank you guys all for being here and for listening to me for the last hour. And obviously I want to thank Denny for bringing me on board and for the rest of the team up in Baltimore for all their support. Thank you. Very hot.
Evaluations and drop them off in the back of the room here. Thank you.
And we're going to have another seminar on March 12th with people who were funded by the Grand Challenge on translational prevention research.
You want to
And, how does our basic studies work, get transferred down to other sciences that are more applied, towards the more applied end of the translational spectrum. So we're going to be trying to frame this for potentially an eventual center if NIH ever decides to fund centers again. Well, they're sort of out of vogue right now as an economic issue. But we are going to try and frame this in a larger way about the work that we're doing and the implications for better understanding differential responsivity and intervention work. So hopefully you all will keep March 12th in mind. Thanks very much. Thank you. That was great.